All right, well, welcome to Astronomy Daily Live. It is 2 hours UTC, actually 2:01 UTC. So, cheers, everyone. It's this is the 30th of July, 2018, and I believe I have figures right. I think the 30th of July, is that the last day of the month, or is that the second to last day of the month? Well, in any case, okay, yeah, second to last day. So we've got 31 days in July, but yeah, things are just flying by, flying by. So yeah, hope everybody's doing well out there. I'm gonna pop up my chat. Uncle Bill is in the chat already. Thanks for coming in, Uncle Bill. You're awesome. Uh, let's see, and I've got Bobby in the panel here. What's going on, Bobby?
Nothing much. Been catching a lot of police activity.
Got a lot of action down there, do you?
Oh yeah, I was on there earlier to just moments just before I log it out and get here. They have like someone being injured with a leg injury, and there was like a young girl that doesn't want to like be out of the house and stuff. So I think they were trying to kick her out.
Yeah, humans are pretty dramatic when it comes to those kinds of things. So yeah, uh,
Adelana's back.
don't. Yeah, I noticed. Atta, hey, nice to see you back. Glad your travels went well. As you can see, I've got the new camera going, so hopefully I'm going to start up my live stream over here on my smartphone, as I usually do, so I can monitor how how terrible it looks. Doesn't look too bad. So trying slightly different lighting in that I'm using less lighting than I normally do with this new
Yeah.
camera.
Now,
I can
Cosmic, if you're still planning on getting the SDRs and you want to track police and EMT activity, I can give you a site in the chat and stuff, and then you go to your state and
right.
then your county to find out what information your sheriff uses and stuff. Now, please be aware that law enforcement may use digital, but no longer analog. Mine uses digital.
Hmm. All right. Yeah. If I eventually want to go that route, I will check it out. Actually, why don't you post something to that effect over on Discord? You can put it on like the miscellaneous channel, um, and that'll be fine. That'll be fine. So yeah, so I turned off the shop light here, so it's not so incredibly blinding. And okay, radioreference.com, cool. Um, huh, Uncle Bill, 100 servers? You are a crazy ninja.
Oh, I posted the link in the chat if you want to like
Yeah,
go.
cool, thanks. Yeah, as I said, feel free to put it over on the Discord as well. I also see that Tom is in the chat, so nice to see you there, Tom. So yeah, new camera finally, and with it, what I got more than anything else was just a little bit more control. Right, I can change the brightness and the contrast and the gain and all that. And as you can see too, it's a slightly wider field of view. You know, I jokingly say that hopefully, I have I've hidden away all the incriminating evidence. I don't I don't think I don't think that there's anything that you shouldn't see. So yeah. So yeah, hope everybody's doing well. You know, this is a daily live stream. Happens every single day, starting at 2 hours UTC, and we talk astronomy for about an hour. It usually goes a little bit more because, well, that's just how I am. And I mean, uh, I could and have um, uh, talk astronomy all day and all night. So it's been my passion since as far back as I can remember, and and uh, and so yeah, I've always been uh, inspired and awed by the universe, and you know, sort of finding tools and methods to to understand it uh, is is great. So okay, yeah, you know that Atta, that might be the aspect ratio. Um, I'm not quite sure what other effect that would be, but yeah, I would characterize myself as a pretty skinny person, I would say. Yeah, I think, well, you know what? I'm sort of right in the middle. Right in the middle. I think I haven't weighed myself in a long time, but I want to say, I don't know, maybe around like 150, something like that. I don't know. I don't pay any attention. I don't really care about those kinds of things anyway. So cheers. I've got a little bit of coffee here. See, you can see the whole mug now. Look at that. Wow. That's incredible. Look at that.
Hey, don't drop it.
No. And even if I do, uh, it's going to land in my lap and just make a big mess.
Oh
So
my
cheers.
god.
I've got some pretty now cool coffee in here, but I'm going to do it anyway. So Atta saw Mars. Yeah. You know, there is a dust storm, and so being able to see surface features probably is going to be a little bit tough. Should be able to see, I would think, at least one of the polar caps. So when you look at it, you might see a little bit of white um, on one edge, and that would be at least one of the polar caps. You might see both, right? And those patches of white would be on um, opposite sides. So, but yeah, dust storm popped up. What about a month ago or so, and also, you know, being able to see detail is pretty tough anyway because we have to look through the atmosphere of the Earth, and that does a lot of interesting distortions and whatnot. So, okay, cool. So you did see a polar cap. Yeah, pretty nice. Pretty nice. So I've also got the hydrogen hydroxide here. It just, yeah, I love this wide field of view. It's great. It puts things sort of in proportion, right? Before this mug was looked absolutely huge, and now it's just a normal mug. So cheers. So Atta, have you gotten so far as to do the star alignment, so your telescope is able to track and all that, or are you still not there? I'm sort of thinking that maybe um, you've picked up on that already. So hopefully, you have. Yes, very cool, very cool. So yeah, you might just be a natural, or just really stubborn. So all right, well, very very cool. Hope everybody's doing well out there. Things are rocking and rolling here. Um, uh, just a reminder um, uh, to hit the thumbs up. Make sure to hit the thumbs up if you haven't already. It's kind of it's a little strange to me, I guess. Maybe that's just because I behave in a different way. But you know, when I see 20 views or 30 views on a video and there are two thumbs up, I'm like, huh, what what's going on with that? So if you haven't already, hit the thumbs up, hit the thumbs down, whichever you prefer. If this is your first time seeing this live stream, either live or later, make sure to subscribe. You can hit the notification bell, and you will be alerted as to when I start. But I always start pretty close to 2 hours UTC. You're going to have to figure out what time that is for your location. Um, and consider that a little bit of a challenge, right? I mean, if you want to get into astronomy, one of the fundamental things that you sort of have to start wrapping your head around is this idea of measuring time. And in the astronomical world, time, of course, is extremely important, but it's also measured in a bunch of different ways. So if you want to get into astronomy, you better get used to thinking about time. So that's why uh, I only give you one time, because actually there only is one time, and that's like right now, right?
It's like it's kind of like a bit crazy, as like we're not like PewDiePie or Damebo or the Report of the Week, but I think it's just a normal YouTube thing to have less views than the bigger boys.
Yeah, totally. Yes, and I totally agree that a lot of people forget the thumbs up or thumbs down. All right, I've got a kitty coming up, and you can actually see the whole, almost the whole kitty.
The
Hi,
Halloween cat.
hi. He probably wants out of this room, is what he wants, and he's just trying trying to communicate. But you know, just like the Star Trek episode that we watched this afternoon um, at 0 hours UTC. That happens every Monday, right? Every single Monday for sure. At 0 hours UTC, I will be going over um, to my Rabbit channel, room, whatever it's called, and screening something. And today it was season 5, episode 2. It's called Darmok, and it's the um, Star Trek: The Next Generation. Um, I don't really like TNG all that much. Not really. But there were a few episodes that were like, you know what? They got that one almost right. So, um, and this is one of them. And so yeah. Um, communication is a tough thing, and you know, I I guess you got to admire a species that is willing to die in order to communicate. So pretty good. It's a little, a little confusing, and one of the things I wonder about, and actually Bobby was in the room too. And so I'll sort of ask you this. Um, do you think the writers um, um, for that episode, when they were writing the lines for the aliens, do you think that, ooh, I've got another one right over there. See here? Dang, dang, dang. Um, do you think that the writers for this episode um, uh, just sort of randomly uh, wrote those lines, or do you think that those lines actually have, some kind of meaning for the writers themselves, or do you think it was just kind of uh, randomly written? What do you think, Bobby?
I think it's a
That makes sense.
I think it's a little bit nerdy and geeky before you ever did her nerdy and geeky.
Yeah, yeah, yeah. Okay, all right. Yeah, Kitty Cam.
And did you take a look at Tom Van Scotter's comment?
I did, and yeah, I that's sort of been my observation too. But I also observe that when viewers are just simply reminded, then the thumbs up just goes tick 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 tick. I mean, it just goes up, right? Yeah, because I mean, you know, one of the things, right, that I'm trying to do here is sort of find our core group. Um, and one of the ways that that is going to happen is through suggested videos. And I think uh, when there are some kind of sufficient number of thumbs up, um, then I think it's more likely for videos to be suggested. And so, if somebody is searching for, like the keyword like astronomy, right, then maybe um, ADL, astronomy daily live, will actually pop up. Who knows? Who knows? But yeah, I'm not trying to cast a net. I'm trying to harpoon viewers. So you're out there, and I'm going to find you. All right. I found kind of an interest. It's 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 difficult on this live stream to um, to talk about sort of the theoretical parts of astronomy. It's pretty hard, mainly because your host, um, would have to um, take a pretty hard look at all of those, and at least try to understand. You know, not to necessarily explain or anything, but just to be able to properly move through those kinds of papers in sort of a reasonable, logical way. Most of the theoretical papers, there's a lot of modeling, there's a lot of mathematics, all of that. No problem with that at all. But the purpose of this live stream um, is to simply share a passion, right? I'm not really trying to teach anything. I'm not trying to communicate anything. Just having a bunch of fun, um, thinking astronomical things, and and so I sort of lean towards the observational because it presents things that don't necessarily have to work too hard at to, for myself to understand, right? Most of the theoretical things are like, as I said, I mean, I would have to spend a little bit of time looking at all of that. And um, I still, I'm going to do this. I want to start a series that's called "What Makes This Paper Great," and I'm not quite sure what that is going to look like, but um, uh, uh, but that's going to take a little bit of studying first, and it's not going to be a live stream, right? I mean, it's going to be sort of a produced thing that, of course, will go up on this channel, but it'll sort of be a different kind of thing altogether, more produced and more more of an educational type of a thing where we where we go through some kind of like famous paper, um, maybe like Einstein's paper that got him the Nobel Prize, say, um, and go through the paper and really see how he worked through that, and explain what he did, all of that, and show what makes this paper great. So that is still lurking in the back of my head here, but for this live stream, since it's just sort of a stream of consciousness thing, um, I'm following my nose, following my curiosity, all of that, sort of lean um, more towards the observational, more towards um, different kinds of instrumentation, different kinds of surveys, that kind of stuff. And along the way, we sort of touch on a few of the theoretical things, um, which I mean, I totally love too, right? So I mean, I could eat mathematics all day long, especially when it's applied um, to astronomy. Having said all of that, I found an interesting paper that I think I noticed before, and they did some kind of revision, and so I saw it again. It came up on archive.org again, and I'm like, you know what? We should look at this because they're presenting some pretty um, tasty looking uh, 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 meals for the head. So I'm going to share my screen just like that. Go to infinity. And we're going to go over to the Discord server. And we'll take a look at this. We'll play around here a little bit. Dun, 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 dun. Slowly. This poor laptop is just really working hard, but working well for us. So I'm going to do that. Okay, Uncle Bill, or I'll have to read all of that later, but I definitely will. So this is called the first data release of the All Sky NOAO source catalog, and I've worked with a couple of these guys. Arjun, worked with him. I've worked with Mike. I've worked with Frank. So these are all NOAO guys. NOAO, by the way, is the National Optical Astronomy Observatories, and they operate Kitt Peak, and I think they have a couple of telescopes down in Cerro Tololo, down in Chile. But so the abstract here was actually the thing that was very compelling. I'm like, man, I need to look at this. So let's go through the paper first, just sort of slam through it, and then get on this what are they calling it? source catalog. Kind of interested in seeing what that is. It's a slow upload or slow download. Look at that. This poor network that I have here. It's amazing. It works at all, and sometimes it doesn't. I don't think it's that long of a paper. Well, it's 18 pages long, so it's not a small paper for sure. Most of the sky has been imaged with NOAO's telescopes from both hemispheres. Almost all of the images are publicly available, but only a small fraction of those have actually been released. That's sort of, scientifically valid data. So, but what they've done, those crazy astronomers, and actually, what Mike and Frank are programmers, right? They're scientific programmers. They know how to handle data and user interfaces and all that. So actually, Mike and Frank were at least two of the developers for IRAF, and I was also on the IRAF team 20 years ago. So I'm starting to get old. But this source catalog, they say, contains over 2.9 billion unique objects, 34 billion measurements, covers a substantial piece of the sky. I think there's something like 40 some thousand square degrees of the sky. So yeah, that's covering a substantial portion, down to 23rd magnitude, which is pretty darn faint. Photometry 1 to 2%, not bad at all. I wish I could get that. I'm still hoping I can. I've got to actually get back on that project. I sort of dropped it, and I need to jump on that thing. And astrometric accuracy, which of course is the measurement of positions of about 7 milliarc seconds. So that's not too bad either, right? 7,000th of an arc, 7,000ths of an arc second, not too bad. So 2 billion objects have photometry in 3 or more bands. So that means you can do some color stuff. So yeah, I mean, all of this is much more than Gaia. And Gaia got a lot of attention, and this isn't getting any. So I'm giving it a little bit of attention. So yeah, a lot of exploration. They don't say anything about spectroscopy. So it doesn't look like there's any spectroscopy. There's just astrometry and photometry. That's good enough. That is good enough. All right, so let's dive into here. One of the things that Kit Peak has done pretty much since the beginning, at least since it's become relatively easy and cheap to store data, is that they have stored and saved every single bit of data. And I think they've been doing that ever since at least the mid 80s, right? So there's just tons and tons and tons and tons of data. And I'm sure some of it is here, and that's and that's how they can produce this kind of a catalog. Let's see. Oh yeah, they're talking about data is just exploding for sure. So let's see, though originally intended for a diverse variety of science programs, these data have a considerable degree of homogeneity. Since the bulk of these data were obtained under different protocols and by multiple principal investigators, they're not conveniently accessed and simply merged. But they've done it. They've done it. So the NSC is now open for business with over 255,000 exposures and 2.9 billion unique objects. So let's look at figure 1. All right, so there it is. So that's everywhere where you see color, you are seeing where the survey covers. And pretty typical doing it in terms of objects per square degree. Of course, that's the logarithm. So these numbers are the exponents of 10. See, so 10 to the fourth would be what, 10,000? So these blue areas, they're showing 10,000 objects per square degree, and sort of the reddest areas here, the center of the galaxy, of course, are showing, well, whatever 10 to the 6.7 is. Pull out my handy dandy calculator, and I can do that calculation. 6.7. I've got a 10 to the x function on here. 10 to the x. 6.7. Oh, I did it the wrong way. I did the log. 6.7. I think I did it again. There we go. 6.7. So that's roughly like 5 million stars per square degree in these areas, in the darker red areas. So pretty good coverage, right? Pretty good. Not too bad. Not quite sure. I guess the reason why some of these are brighter here is because they're seeing fainter objects, and the fainter the object is, the more you're going to see. So that's sort of my guess as to why, these are a little bit brighter than those. So not too bad though. Right. Okay. And it actually says that, right? True density of the objects as well as the exposure time. Exposure time. Yeah. Which is directly proportional to the limited magnitude of your object. So all data is drawn from the NOAO Science Archive. A large majority of the data is coming from the dark energy camera. 195,000 exposures. Woohoo! So yeah, they just they created a what's called a pipeline, to sort of process these images, right? You shove them into the front, and they're calibrated and corrected, and all the junk removed and all of that. And what you get at the end of the pipe is some nice, pretty data. So okay, well there's all of that. What is this? Okay, so these are just all the surveys that went into this. So that's cool. You can see the wavelength bands here that they used. Average seeing, not too bad. You know, this is Kid Peak and CTIO, so you know, some of the best skies in the world. Let's see, I'm not sure what's going on here. RMS versus the number of Gaia matches on a logarithmic scale. I'm not quite sure what that's all about. We'll keep moving here. The CPs, okay. Well, we're starting to get into some cryptic wording here, so let's go back. The community pipelines, okay. The community pipelines, what do they say about that? Community pipelines create several types of images, instacals, and resampled and stacked. Okay, cool. Oh, what else do we have here? The main calibration operations. Okay, so this is just a part of the pipeline, right? So let's see. Linearity, correction, crosstalk, bias, gain, which is similar to flat field. So all the nasty pixels are identified. Not quite sure what that is. And then, yeah, it's put into the so-called world coordinate system. I'll be right back. I just have to play doorman here just for a second. Hold on. So they get rid of all the cosmic rays, sky patterns and gradients, pupil ghosts, fringe pattern, flat field, all kinds of stuff. You know, you gotta, I mean, if you want to just measure, right, the light that is coming from the object that you're interested in doing, you've got to take all of this into account. So you know, it's not easy. So they used source extractor. So that's cool. I don't know where source extractor was developed. I don't know if that's an NOAO thing or if that's something else. So one of the goals of the catalog is to achieve uniformity across survey in the detection limit for all filters and scene conditions, and to also perform well in crowded and uncrowded regions. Cool. So yeah, lots of objects with low signal to noise, right? Less than 10, but lots of objects that have nice high signal to noise too. It's cool. Let's see, I'm not gonna too much into this. What are these? It's like model magnitude figures showing the density of stars in residual magnitude versus color with a separate panel for each band. Huh. Okay. Some of these things I don't quite follow. I think, again, it's sort of the case where it's like, probably if I were to study this a little bit more, I could get into it. But I said, this isn't this live stream isn't really to educate everyone. It's just to look at stuff, go through this, see what we can skim off the top at least. Sometimes we can dive deep, but sometimes not. Bottom line is, right, is that they've done quite a bit of work here to understand what they're dealing with, and if you understand what the limitations are, what your parameters are, then you can sort of intelligently go through the data and have some confidence, at least to some level, right? And that's pretty much what all this is explaining. Is just how good is the data that they have, and being um, open and honest about it is necessary, right, in order to do good science. So I'm not quite sure what they're doing here, but looks like they've got some pretty good looking stuff for sure. Cross matching combined to the final stage. So these are model magnitude equations. So this is how they can sort of move between different filter systems. And that can be useful if you're using a bunch of different survey data. Like if you want to use this and Gaia, well, you have to correct a little bit for certain systematic differences between those two systems, and those are the equations that will allow you to do that. All right, what are these? Lots of some maps of the photometric RMS scatter of bright stars. Okay, so I sort of read that as yeah, the uncertainty in the measurements. So pretty low where you've got bright things, and pretty high when you've got some faint things. That all makes sense. So they've just got lots of. I was hoping that we could dive into this and actually extract some data, look at a few images. Don't know if that's going to happen or not. See what else we got here. Mean photometric 0 point. Ooh-wee. Yeah. This is quite involved for sure. simple and astronomically useful. Wow. I don't know about the simple part. What is this? Depth maps. That's just showing how faint they can actually go at different wavelengths. But they're claiming like magnitude 25.1 in G, so that's pretty good. That's pretty awesome. 25.2. Not too bad. Number of exposures. Interesting. Always interesting to see how various pieces of data are going to be represented. That's kind of an interesting one. Number of exposures. Kind of cool. It's also kind of interesting that this doesn't match that first one that we saw. So I'm not quite sure what's going on there, because the first one we looked at was like a target density, and I would think that wherever they have an exposure, they have a measurement of that. But I remember seeing some big gaps over here, right? So I don't know what's going on there. What I'm really looking for, on top of sort of just wanting to go through the papers, I wanted to go to the site, to the actual site, and so these are color magnitude diagrams. They can also be interpreted as Hertzsprung-Russell diagrams. And so we're seeing some interesting structures here. Kind of interesting. Okay, so this, I think they're just doing a comparison, right, between this thing that they're calling SMASH, which is probably another catalog of some sort, and the this catalog. So yeah, similar, I guess. There are some differences for sure, but yeah, pretty good. Now let's see. We need to find the actual website. Let's see if I didn't see it on our first scan. So let me go all the way back to the top and see if we can find it. It doesn't look like that's it. I know that over on the archive itself, I think they had a link. So let's look there. Archive.org is totally awesome, as I've said many, many times, and will say many, many times again. This thing was way at the bottom here. It was actually a replacement paper. Here it is. Let's see. There it is, datalab.noao.edu. Let's go there. The 34 billion row measurements. Okay, so let's see here. What I want is to be able to access data. Survey data. Oh. Survey coverage. Why am I not seeing... Why am I not seeing the... Oh, haha. It's got to be right in front of my face. Then I won't see it at all. Here we go. Here's a little bit more detail. 30,382 square degrees. 2.9 billion objects. 34 billion measurements. Data access. Here we go. It's not going to be easy, is it? Accessible by a variety of means. And I was hoping that they would have a nice web access tool. Doesn't look like it. Tap where clients can point to there. Yeah. Query manager is available as part of the Data Lab software distribution. Jupyter Notebook server. Shoot. Doesn't look like we're going to have easy access. Thought it would be a thing where we could, a lot like the HST images where we can just, punch in an object name or like a right ascension and declination and get stuff back, but it doesn't look like. Maybe. Oh, maybe. Discovery tool uses Aladdin Light. Okay, well, we know about Aladdin Light. Just sort of rotate around and stuff. Yeah. Okay. So that's kind of cool. Here's the large and small Magellanic clouds. Here's the galactic center. Of course, the center's over here. I grab it. Yeah. That's pretty cool. But what I really want is... So that's the source catalog. So I've never played with this. So you and I are going along for the ride here together. Bet you there's a way. Is there a way to zoom in? Well, I'll bet you can zoom in. Yeah. Okay. And then I think there's a overlay. What that's going to do. Opacity. Let's make it 100% opaque. I don't see anything. Oh. Don't see much there. Image centers, overlay catalog layers, overlay image layers. Yeah, why can't we see... shouldn't I be able to see images there? I don't see any images. Opacity 0, opacity 100. I don't see anything changing. Reverse. That's cute. Native. So let's zoom in here. I'm not seeing anything. definitely sort of a picture of the sky, sort of. What does this do? Grayscale doesn't seem to change much of anything. You can see up here, this is showing right ascension and declination as I move around. What are these things? Manage layers. What does that do? Okay, huh. Don't see much there. What does this thing do? Select catalog, go to position. Let's turn that off and go to one of these other ones just to sort of see what the difference is. So there's a few things changing there. What does this one do? But I'd really like to actually get some data. This is not going to let us do that, which is a bummer. I was hoping to be able to grab some images off of this and play with them, but it sort of looks like I'm going to have to look into this a little harder, see if I can work out exactly what I need in order to get this. I'm just sort of wondering what would happen if I went to this site right now. I don't know. Let's just grab this and copy it and paste it over here. Let's just see what this does, huh? Uh-oh. That's probably no good. The requested resource is not available.
You need a client to access that.
Yeah, I think so. I think I'm gonna have to do a little bit of homework here to get this accessible. So I'm sort of thinking that maybe I want to do this one, but yeah, maybe. I don't know. Yeah, I guess I'll have to poke around a little bit. See, but you know, I'm here again. You know, we have us armchair astronomers out there, who don't have telescopes, don't have big scopes, don't have all the instrumentation that the pros use. We've got access to all of this, though. Sometimes, as you can see, it's a little bit difficult to gain access, but so you got to be a little bit stubborn and a little bit determined, but it can be done. So cheers. Now, what do you think of the lighting here? Is this a little dark? Is this okay?
Still okay to me.
Yeah. Okay. I might, I sort of anticipated, that maybe I would have, some lighting things that I'm going to have to mess around with. Let's see, I can change the position of this light down here. And so, yeah, I'll play around a little bit. It's this is an always evolving live stream. know, one of the big goals is to just get better every single day. So that's what I'm going to do. So cheers. And I think that I'm going to get out of here. I think, yep, I am hearing the call. I'm hearing the call. So yeah, I think I'm gonna get out of here for today. Make it a little shorter live stream than normal, but wow, you know, we've got another source of data. I don't know if you noticed the flash on the window there. That's lightning. So yeah, we've got. I guess we've got some storms um, in the area. The monsoons are back a little bit here, and oftentimes when we get storms, we also lose power. So yeah, I think the timing is about right to get out of here for now. So thanks for coming in again. Thanks, Bobby, for being on the panel
Not a
again.
problem.
Um, it's always great. I'd like to actually fill up the panel, right? I think I can have like up to 10 slots here. So um, if anybody's ever interested in getting on the panel, you don't have to every time. Um, just send me an email, cosmiclettuce@gmail.com, and I'll send you a link when I start up the Hangout here, and then you can pop on. I guess, you know, click on that link and you magically appear. So pretty cool, pretty cool. All right, well, as I said, I think I'm going to get out of here for today. In just a little less than 23 hours, we will all be back. One more spin of this planet. Oh, there goes some more lightning back there. All right, well, very, very cool. Yeah, I think that's it for today. So I will see you next time. You can come onto the panel as anything you want, Ata, especially for Uncle Bill. So, all right, take care, everybody. I will see you on the spin. Bye.